Alright, so we have one more thing to go over that's going to be on the test on Tuesday that I want to make sure you guys have the notes on. There are two parts to this one theorem, it's the triangle inequality theorem. So part one is that the measure of the angles is directly connected to the length of the sides. Okay, so all this means is that if you put the angles in order of measure, the opposite sides of the triangle would be in the same order. So for example, for this one, since A is the smallest angle, which is over here, then CB is the smallest side. Since B is the middle-sized angle, AC, which is the opposite side, is the middle-sized side. And since C is the largest angle, the opposite angle is, or the opposite side is AB, is the longest side. So if you're ever confused, go ahead and draw some arrows to connect. Whatever you can start at an angle and draw a straight line across, that's what I mean by opposite side. So A goes with BC, B goes with AC, and C goes with AB. So the reverse is also true, all right? For something like this, right, you can put the sides in order, largest to smallest. BC is the largest, AC is the second largest, AB is the shortest. So the opposite angles are going to be in that order. Angle A is the largest. Angle B is opposite, that's the middle size. Angle C is the smallest. Still don't assume anything, you've got to go with the numbers. I have seen tests and quizzes be written where they'll put this shape to it, but they'll make this the longest side to see if you're paying attention to the numbers. Alright, so this is also going to imply that if two sides have the same measure, their opposite angles have the same measure. So when AC and AB are exactly the same, angle C and angle B are going to be exactly the same. So that's the first part of the theorem. The second part of the theorem is that if you're missing a side length, you can use the other two sides to make a range of numbers that the missing side length could be in. Alright, so if you're missing the side, we can't find the exact side per se, but we can find a range of where it could be. We can find a group of possibilities. So first thing we do is you add the two numbers. You add the two numbers you're given, and that's the top end of the range. You subtract the two numbers you're given, and that's the bottom end of the range. So an example of what it would be, and there's the notes. An example of what it would be is if the side lengths are 4, 8, and x, the range of values for x are, and you start with 8 minus 4, and that's 4, and 8 plus 4, and that's 12. So that means your range is it's got to be greater than 4 and less than 12. So some examples of some problems you will see. So put the angles in order and measure from smallest to largest. And you notice they don't give you any angle measures. They give you side lengths. So it wants the angles to be in order from smallest to largest. So you start with the side, the smallest, that's AB. So we're going to start, angle C is going to be the smallest. Then we start with the next smallest number. Across from that is angle A. That's going to be the next smallest angle. Then we start with the next smallest, or the largest angle, and go across from that, and that's going to be your, or excuse me, start with the largest side, and that's going to be your largest angle. So C, then A, then B, according to the sides. Another question you may see is put the sides in order of measure from smallest to largest, and they only give you the angles. So I'm going to look at my from smallest to largest means I start with the smallest, which is C, and I go across. Then my next one's going to be this one over here. Then my last one's going to be my biggest one, which is this guy over here. So it should be AB, then BC, and then AC. Excuse me. Yeah, that's right. AC being down here, across from B. Alright, so another one they may give you is they may draw you a triangle and say find the range of possible values. So you take your two numbers, you subtract them, that's your bottom of your range, and then you add them, and that's the top end of your range. Put your x in the middle because I don't know what x is. It has to be greater than 7 and less than 23. Note, not greater than or equal to, greater than 7. So x can't equal 7. X cannot equal 23. It's got to be a range between them. Last example, can the following side lengths make a triangle? So if I'm given a shape and I've got it labeled 2, 3, 4, will that actually make a triangle? So what I'm going to do is I'm going to take my two smallest numbers, I'm going to add them up for the top end of the range. I'm going to take my two largest and I'm going to subtract them for the bottom end of the range. So I find a range of 1 to 5, and then I go back and check, are all these numbers between 1 and 5? Yes, they are. Yes, it makes a triangle. All right. My next side lengths are 8, 8, and 8. Well, you should already know that would make a triangle because we have equilateral triangles and those are allowed. But if you want to test it correctly, you take two of them and you subtract it and you get 0. You take the other two and you add it and you get 16. So any range between 0 and 16, you check and make sure all these numbers are between 0 and 16. They are. Yes, this could make a triangle. So what about this next one here? So 3 plus 9 is 12, which is right there. Then I've got 12 minus 9. So you take your two smallest and add them, your two biggest and subtract them. And you create a range between 3 and 12. Do all these numbers fall between, and that's the important part, between 3 and 12? No. The side lengths cannot be on the range. So these would not make a triangle. And last but not least, 2, 4, and 15. So I would add 2 plus 4, get 6. So that's the bottom end, or the bottom end of my range. And then 15 minus 4 is 11. So anywhere between 6 and 11, the numbers are not in the range. It will not work. Okay? So these cannot make a triangle. So the gist of this is you add the two smaller numbers, subtract the two bigger numbers. This creates a range that all numbers should be in, right? So this creates a range that all measures of sides should be in. Thanks, guys. Have a good weekend.